All right, if you're getting into data science, machine learning, or really any kind of heavy-duty computing with Python, there's one library you absolutely have to know. It's kind of the engine running under the hood of everything else. So today we're digging into NumPy, the undisputed powerhouse of Python data science.
So, here's the game plan. First, we'll see why NumPy is the bedrock of scientific Python. Then, we're going to uncover the secret behind its crazy speed. After that, we'll check out its two main superpowers, vectorization and broadcasting. Then we'll see how it's used in the real world to turn data into insights. And finally, I'll show you exactly how to get started right away.
Okay, let's start at square one. What exactly is NumPy? Well, at its core, it's the foundation for the entire scientific Python world. And it's all built around one single powerful idea, the n-dimensional array.
NumPy, which you guessed it, stands for numerical Python, gives us this amazing tool called an ND array. You can just think of it as a grid of values. But here's the cool part. It's a grid that can have as many dimensions as you want, and it's been hyper-optimized for one thing and one thing only, blazing fast calculations. This ND array, it's the key to everything.
So that brings up a really important question. I mean, Python already has lists for storing stuff, right? So why did we even need to invent something new? The answer comes down to one word: speed. We're talking game-changing, mind-blowingly fast speed.
So what's the secret sauce? Why is a NumPy array just so much more efficient for doing math than a regular old Python list? Well, it all comes down to what you're allowed to put inside it.
Think about it this way. A Python list is like a junk drawer. You can throw anything in there, some numbers, some text, whatever you want. It's super flexible, but that flexibility makes it slow for math. A NumPy array, on the other hand, is like a specialized socket set. Every single tool, every single element has to be the exact same type. This strict rule makes it incredibly efficient and lets it perform calculations at lightning speed.
And it's this strict, uniform design that unlocks NumPy's two most famous superpowers. These are the features that let you handle massive amounts of data with just a couple of lines of code. Let's talk about vectorization and broadcasting.
First up, we've got vectorization. Now, this is a huge deal. It's the ability to do an operation on a whole array all at once, without having to write one of those slow, clunky Python for loops that goes through each item one by one.
Check this out. We can make an array with the numbers 1, 2, and 3. Then, in one simple move, r times 10, bam! We've multiplied times every single element by 10. No loops, no hassle, just one clean, fast operation. That's vectorization for you.
NumPy's other superpower is called broadcasting. And honestly, this is where things start to feel a little bit like magic. Broadcasting is NumPy's incredibly smart way of letting you do math on arrays that don't even have the same shape or size. So here's how it works. We have a simple one-dimensional array, A1, and a bigger two-dimensional one, A2. Now, normally, you couldn't just add these together, but with broadcasting, NumPy is smart. It virtually stretches out the smaller array to match the shape of the bigger one, so the addition can happen element by element. It's just incredibly clever and powerful.
Okay, so all this speed and power is really cool, but what does it actually let us do? This is where we see NumPy's real-world impact, how it helps us turn messy data into actual useful insights. With NumPy, you basically have a whole universe of tools right at your fingertips. You can instantly calculate things like the mean, the sum, or the standard deviation of millions of data points. You can do complex linear algebra like multiplying matrices. You can generate random numbers for simulations, and believe me, that is just scratching the surface.
So just how big is this universe of tools? Well, take a guess. How many powerful functions do you think are built right into NumPy? Get this, the answer is 532. That is a massive amount of computational power ready to go right out of the box.
And here is the single most important thing to understand. NumPy doesn't live in a bubble. It's the engine that powers almost every other major data science library out there. You've got pandas for data wrangling, matplotlib for making charts, and scikit-learn for machine learning. They all have NumPy's fast arrays working tirelessly under the hood. So learning NumPy is really the first step to mastering the whole stack.
So you've seen the power, you've seen the potential. You ready to jump in? The best part is that getting started is unbelievably easy. Let me show you exactly how to get this powerhouse library up and running on your own machine.
It's literally just 2 steps. That's it. First, you open up your terminal or command prompt and just type in that simple command, pip install NumPy.
Once that finishes, you just add one line to the top of your Python code, import numpy as np, and you're done. You are ready to rock.
Hey, if this explainer helped clear things up for you, do me a favor and hit that subscribe button and give this a like. That way you won't miss out on whatever we dive into next.
And for more awesome, hands-on tutorials for Python and a bunch of other languages, you should definitely visit the source for today's material, www.plus2net.com. It's a fantastic place to keep learning.
So I'll leave you with this final thought. Now that you know about the incredible speed and all the amazing things this library can do, the only real question left is, what complex, interesting problems are you going to solve with the power of NumPy?